comparison tests. Now, when it comes to comparison tests, the idea is that if we are given a series, right? Let's say n squared plus 2 over 1. We compare it to another series that we don't know exactly if this series converges or diverges, but we can compare it to another series that we do know if it converges or diverges. So for example, if we have 1 over n squared, now we know that this series converges, right? So since this is 1 over n squared plus 1, and this is 1 over n squared, we know that 1 over n squared plus 2, n squared plus 2 is less than 1 over n squared because there's a greater number on the denominator. So from this, we can decide that if this converges and this is less than this, then that must mean that it is less than a whole number, meaning that it also converges. So by direct comparison, this series converges because this other series also converges. Now, this doesn't work in the case of the series of there over n plus 1, because the series we would be comparing to, 1 over n, now this diverges. So from what we can say is that 1 over n plus 1 is less than 1 over n. Well, if this is infinity, this will go to infinity. Then all we're saying is this is less than infinity. But it can still be infinity. It could just be so that this one grows to infinity faster. So what we're going to have to do is something called the limit comparison test. Now, for the limit comparison test, we do the limit of a sub n over b sub n as n approaches infinity. And if this limit is equal to, let's say L, is between 0 and infinity, they will both behave the same. So, for example, this diverges, so what we're going to do is a sub n is 1 over n plus 1, and since we're dividing by 1 over n, we're going to end up with something like this. There, that goes on top, that's on bottom, because they're working with fractions, so it's going to be reversed. This is a sub n in this case, this is b sub n, and now if we evaluate this limit, well, we know that due to L'Hopital's, or just the fact that this is a 1 in front of this, is 1 in front of this, is equal to 1 over 1, which is equal to 1. There's an asymptote right there. But from this, we can tell that this limit is equal to 1, which is greater than 0 and less than infinity. So what that says is that these two series right here behave the same. So since they behave the same, if this one diverges, then this one also diverges due to limit comparison, because we cannot directly compare them.